Hi students, now we'll talk about instantaneous velocity. It is different than the average velocity. Remember me in the previous example? I was initially at point x equal to 0 at time t0, which is the original. And in the first action, I go to point x equal 30. And the time was 60 seconds. And my average velocity, if you remember, it was delta x over delta t, which is a half meters per second. Delta x over delta t, remember this notation. Delta means the change in position between two vast positions, okay? But what if we take the time or the change in position to small values? Because any body is move small, tiny small displacements at a time, not change from 0 to 30 instantaneously. It is gradually, okay? But if I reduce the period of time to be very small, very small, it will not be delta t, it will be dt for small, tiny, small periods of time. In this case, I will not have in my question or my problem delta x, which is a vast change in position. It will be dx. dt is the same delta t, but when delta reaches 0 or reaches small number, a small value. And the same for the dx. It is the same as delta, but it is the limit for delta when delta goes to 0. So for infinitely small periods, delta t will go to dt, and delta x goes to dx, or in different mathematical notations, the limit of delta x over delta t when delta t goes to 0 is dx by dt. This is the instantaneous velocity, okay? It is the derivation. It is the derivative. Did you remember before the example? We just have this simple sheet. If we have f of x, if you remember that, x squared plus 2x plus 1. What is df by dx? It is equal to 2x plus 2 plus 0. If you remember that, it is the same delta f over delta x. We need to take the limit when delta x goes to 0. This will give us df by dx, which is the first derivative. Now we see that the first derivative of x with respect to t is the instantaneous velocity. For example, if we take this x as a function of t, x of t is equal to 3t cubed minus 4t squared plus 5 in meters, okay? If I ask you to find the position at time equal 3 and name it x2, I need just to put t equal to 3 in this function. It will be 3 multiplied by 3 cubed minus 3 squared plus 5. It will be 50 meters. What about x? If I name it x1 or x initially at t equal to 0, I just need to put 0 in place of t. It will be 0 minus 0 plus 5. Okay, what if I need to calculate v average between the time 0 and 3? It is easy. I need to find delta x over delta t. I have x1, x2. Delta x is x2 or x final minus x initial, which is 50 minus 5. I name this one 2 and this one 1. 50 minus 5, which is 45, over the change in time, which is 3 minus 0, which is 3. This will be equal to 15 meters per second. I can find the average velocity if I have the function of the position in time. What about the instantaneous velocity? That's easy. I need to take not delta x over delta t. I need to take the first derivative of x with respect to t, which is dx over dt. This is a calculus course, so I can derive this with respect to t. Assume it in x, assume it f of x is equal to 3x cubed minus 4x squared plus 5. What is df by dx? It is easy. 3 by 3, which is 9x squared, minus 2 by 4, which is 8x plus 0. I don't have f, I have x, and don't have x here, it is t. So I have dx by dt, the change in position in time, which is equal to 9, I don't have x, it is t squared, minus 8t. This is it. I have the instantaneous velocity as a function of time, yes. This is t. You will find it right. Just a typo here. It is t squared, 9t squared minus 8t plus 0. Okay, now if I need to find the instantaneous velocity, okay, I have the velocity as a function of t. Just I need to put the time that I need the instantaneous velocity at that time as a function of this v. So the instantaneous velocity at t equal 3, just I put the 3 here. It is 9, 3 squared, negative 8 multiplied by 3, which is 75 meters per second. What is the instantaneous velocity at t equal to 0? I need to put 0, 0, it will be 0. What is the instantaneous velocity at t equal to 1? Put 1, 1 squared is 1, 1 is 1. This will be 9 minus 8, it will be 1, the instantaneous velocity. And so on. You can try that by yourself. And we will do it in the class. See you. Bye.